Introduction. Chemical change is permanent change. In a chemical change, two substances react chemically to form new substance with different properties. Temporary, permanent, natural, man-made changes, etc. They may be categorized into two types known physical changes and chemical changes. The reactions taking place during the occurrence of these processes. Coal is burnt, food gets digested in our body. Iron nail is exposed to humid atmosphere for a long time. We respire. Milk is converted into curd. Water is added to quicklime. Crackers are burnt. Activity. Take about 1 gram of quicklime in a beaker. Add 10 ml of water to this. Touch the beaker with your finger. The beaker is hot. The reason is that the calcium oxide reacts with water and releases heat energy, while calcium oxide dissolves in water, producing colorless solution. Dip the red litmus paper in it. Red litmus changes into blue color. We conclude that the solution obtained is a basic solution. Activity. Take about 100 ml of water in a beaker. Dissolve a small quantity of sodium sulfate, that is Na2SO4, in it. Take about 100 ml of water in another beaker. Dissolve a small quantity of barium chloride, that is BaCl2, in it. Add the two solutions. We will get a white precipitate of barium sulfate. Na2SO4 plus BaCl2 gives BaSO4 plus 2 NaCl. Activity. Take a few zinc granules in a conical flask. Add about 5 ml of dilute hydrochloric acid to a conical flask. Observe the changes in a conical flask. Keep a burning matchstick near the mouth of the conical flask. The light of burning matchstick put off with pop sound. This indicates the H2 gas has released in the reaction. When we touch the bottom of the conical flask with our finger, we feel hot. So, this reaction produces heat. Chemical equations. Calcium oxide reacts with water, a new substance is formed, is unlike either calcium oxide or water. The description of chemical reaction is a sentence. In activity 1 is quite long. Calcium oxide plus water gives calcium hydroxide. The substance undergo chemical change in the reaction are called reactants, and the new substance formed are called products. A chemical reaction is the form of word equation, shows the change of reactants to products by an arrow placed between them. If there is more than one reactant or product involved in the reaction, they are indicated with a plus sign between them. Writing a chemical equation. Generally, a compound is written by giving its chemical formula, which lists the symbols of the constituent elements and uses the subscript to indicate the number of atoms of each element present in the compound. Calcium oxide as CaO, water as H2O, and the compound formed by the reaction of these two compounds is calcium hydroxide. CaO plus H2O gives rise to CaOH2. The number of atoms of each element on left side and right side of arrow. Zinc metal reacts with dilute HCl to yield ZnCl2 and liberates hydrogen gas. Zn plus HCl gives rise to ZnCl2 plus H2. Sodium sulfate reacts with barium chloride to give precipitate barium sulfate. Na2SO4 plus BaCl2 gives rise to BaSO4 plus NaCl. Balancing chemical equations. According to the law of conversion of mass, the total mass of the products formed in chemical reaction must be equal to the mass of reactants consumed. The smallest particle of an element that takes part in the chemical reaction. The mass of any substance. The number of atoms of each element before and after reaction must be the same. All the chemical equations must be balanced. Because atoms are neither created nor destroyed in chemical reactions. The chemical equation in the numbers of atoms of different elements on the reactant side are same as those on product side is called a balanced reaction. A formula unit, as the name implies, is one unit. Atom, ion, or molecule corresponding to a given formula, one formula unit of NaCl. Example, 1 Na ion and 1 Cl ion. One formula unit of MgBr2 is 1 Mg2 plus ion and 2 Br minus ions. And one formula unit of water is 1 H2O molecule. The chemical equation using a systematic method. Example 1. Hydrogen reacting with oxygen to form water. Step 1. The equation with the correct chemical formula for each reactant and product. Example, the reaction of hydrogen with oxygen to yield water, chemical reaction as follow. H2 plus O2 gives rise to H2O. Element, number of atoms, LHS, RHS, H, 2, 2, O, 2, 1. Step 2. The molecular formula of the substances, the equation is to be balanced. The ratio of atoms in the molecules of the substances, but the suitable numbers as the coefficients before the formula. The above equation 2 before the molecular formula of hydrogen and also 2 before the molecular formula of water. Observe atoms of both the elements hydrogen and oxygen are same or different on both the sides. 2H2 plus O2 gives rise to 2H2O. Step 3. The coefficients of all the substance getting divided a suitable number. The lowest ratio of coefficient for reactants and products, the above equation needs no division of the coefficients of the substance. Step 4. The equation for the balancing of atoms on both sides of equation. Combustion of propane C3H8 propane, C3H8 is a colorless, odorless gas often used as a heating and cooking fuel. The chemical equation for the combustion reaction of propane. The reactants are propane and oxygen, and the products are carbon dioxide and water. The reaction in terms of symbols and formulate of the substance involved and follow the 4 steps described in previous discussion. Step 1. The unbalanced equation using correct chemical formula for all substances. C3H8 plus O2 gives rise to CO2 plus H2O. Note: chemical equation containing molecular formula for the substance is known as skeleton equation. Step 2. Compare number of atoms of each element on both sides. The coefficients to balance the equation. It is better to start with the most complex substance. In this case, C3H8 element, number of atoms LHS, RHS, C, 3 in C3H8, 1 in CO2, H, 8 in C3H8, 2 in H2O, O, 2 in O2, 3 in CO2, H2O. The skeleton equation, and note that there are 3 carbon atoms on the left side of the equation, but only 1 on the right side. Add a coefficient of 3 to CO2 on the right side, the carbon atoms balance. C3H8 plus O2 gives rise to 3CO2 plus H2O. The number of hydrogen atoms. There are 8 hydrogen on the left, but only 2 on the right side. By adding a coefficient of 4 to the H2O on the right, the hydrogen atoms get balanced. C3H8 plus O2 gives rise to 3CO2 plus 4H2O. Finally, look at the number of oxygen atoms. There are 2 on the left side, but 10 on the right side. By adding a coefficient of 5 to the O2 on the left, the oxygen atoms get balanced. C3H8 plus 5O2 gives rise to 3CO2 plus 4H2O. Step 3. The coefficients are reduced to their smallest whole number values. The coefficient in smallest whole number, there is no need to reduce its coefficient, but this might not be achieved in each chemical reaction. 2C3H8 plus 10O2 gives rise to 6CO2 plus 8H2O. The equation is balanced. The coefficients are not the smallest whole numbers. It would be necessary to divide all coefficients of equation by 2 to reach the final equation. C3H8 plus 5O2 gives rise to 3O2 plus 4H2O. Step 4. The numbers and kinds of atoms on both sides of the equation. Example: iron oxide reacts with aluminium to form iron and Al trioxide. The chemical equation to show the reaction and balance it. Step 1. The correct chemical symbols and formulae for all the reactants and products. Fe2O3 plus Al gives rise to Fe plus Al2O3. Step 2. The suitable coefficient for the reactants and products to equate the number of atoms of each element on both sides. Elements: number of atoms in reactants, number of atoms in products. Fe, 2 atoms in Fe2O3, 1 atom in Fe. O, 3 atoms in Fe2O3, 3 atoms in Al2O3. Al, 1 atom in Al, 2 atoms in Al2O3. Number of oxygen atoms is equal on both sides. The remaining atoms. There are 2 Fe atoms on left side. There is 1 of the atom on right side. To equate number of Fe atom, multiply Fe by 2 on product side. Fe2O3 plus Al gives rise to 2Fe plus Al2O3. The above equation, number of aluminium atoms still unbalanced. There is 1 Al atom on left side and 2 Al atoms on the right side. To balance Al atoms on both sides, multiply Al by 2 on left side of arrow mark. Fe2O3 plus 2Al gives rise to 2Fe plus Al2O3. The above equation, the number of atoms of each element is same on both sides of arrow mark. This is a balanced chemical equation. Step 3. The above equation is balanced and coefficients are also smallest whole numbers. Step 4. Finally, the correctness of balanced equation, count the number of atoms of each element on both sides of equation. Fe2O3 plus 2Al gives rise to 2Fe plus Al2O3. Element, number of atoms of reactants, number of atoms in products. Fe, 2 atoms in Fe2O3, 2 atoms in Fe. O, 3 atoms in Fe2O3, 3 atoms in Al2O3. Al, 2 atoms in Al, 2 atoms in Al2O3. Note: the above method of balancing is called trial and error method only. Sometimes to take more care to balance the equation. Making chemical equations more informative. Chemical equations made informative by expressing following characteristics of the reactants and products. Physical state, heat changes, gas evolved, precipitate formed. Expressing the physical state. The chemical equation more informative. The physical state of the substance may be mentioned along with their chemical formula. The different states, that is, gaseous, liquid and solid states, are represented by the notations G, L and S respectively. The substance is present as a solution in water. The word aqueous is written. Fe2O3 S plus 2 gives rise to 2FeS plus Al2O3S, that is, in solid states. Expressing the heat changes. Heat is liberated in exothermic reactions and heat is absorbed in endothermic reactions. C, solid plus O2 gas gives rise to CO2 gas plus Q. Exothermic reaction. N2 gas plus O2 gas gives rise to 2NO gas minus Q, that is endothermic reaction. Q is heat energy with plus sign on product side for exothermic reactions and minus sign on product side of endothermic reactions. Expressing the gas evolved. If a gas is evolved in a reaction, it is denoted by an upward arrow or G. Example, Zn solid plus H2SO4 aqua gives rise to ZnSO4 aqua plus H2 gas is evolved. Expressing precipitate formed. A precipitate is formed in the reactions. Example, AgNO3 aqueous plus NaCl aqueous gives rise to AgCl solid plus NaNO3 aqueous. Sometimes the reaction conditions such as temperature, pressure catalyst, etc. are indicated above and or below the arrow in the equation. Example, 2AgCl solid when reacted with sunlight gives rise to 2Ag solid plus Cl2 gas, 6CO2 gas plus 6H2O liquid when reacts with sunlight with catalyst chlorophyll gives rise to C6H12O6 solid plus 6CO2 gas. Interpreting a balanced chemical equation. A chemical equation gives information about the reactants and products through their symbols and formulae. It gives the ratio of molecules of reactants and products. As molecular masses are expressed in unified masses, the relative masses of reactants and products are known from the equation. The masses are expressed in grams, then the equation also gives the molar rations of reactants and products. If gases are involved, can equate their masses to their volume and calculate the volumes or those gases liberated at given condition of temperature and pressure using molar mass and molar volume relationship. Using molar mass and Avogadro number, calculate the number of molecules and atoms of different substance from the equation. Mass, mass relationship, mass volume relationship, volume volume relationship, mass volume number of molecules relationship, etc. Example, Al solid plus Fe2O3 solid gives rise to Al2O3 solid plus Fe solid. Atomic masses of Al equals to 27U, Fe equals to 56U and O equals to 16 units. 2Al solid plus Fe2O3 solid gives rise to Al2O3 solid plus 2Fe solid. 2 into 27 units plus 2 into 56 plus 3 into 16 units gives rise to 2 into 27 plus 3 into 16 units plus 2 into 56 units. 54 units plus 160 units gives rise to 102 units plus 112 units, or 2 mole plus 1 mole gives rise to 1 mole plus 2 mole. 54 grams plus 160 grams gives rise to 102 grams plus 112 grams. Calculate the amount of aluminium required to get 1120 kg of iron by the above reaction. Solution. The balanced equation: aluminium gives rise to iron 54 grams, 112 grams. X is what? 1120 into 1000 grams. Therefore, X gram equals to 1120 into 1000 grams into 54 grams divided by 112 grams equals to 10,000 into 54 gram equals to 54,000 gram or 540 kg. To get 1120 kg of iron, we have to use 540 kg of aluminium. Example: calculate the volume, mass and number of molecules of hydrogen liberated when 230 gram of sodium reacts with excess of water at STP. 2Na solid plus 2H2O gives rise to 2NaOH aqueous plus H2 gas evolved. 2 into 23 units plus 2 into 1 plus 1 into 16 units gives rise to 2 into 23 plus 16 plus 1 units plus 2 into 1 unit. 46 unit plus 36 unit gives rise to 80 units plus 2 units, or 46 gram plus 36 gram gives rise to 80 gram plus 2 gram. Solution. The balanced equation: 46 gram of Na gives 2 gram of hydrogen. 230 gram of Na gives how many gram of hydrogen? 230 gram into 2 gram by 46 gram equals to 10 gram of hydrogen. 1 gram molar mass of any gas at STP, that is standard temperature 273 kilo and standard pressure 1 bar, occupies 22.4 liters, known as gram molar volume. Therefore, 2.0 gram of hydrogen occupies 22.4 liters at STP. 10.0 gram of hydrogen occupies how many liters at STP? 10.0 gram into 22.4 liters divided by 2.0 gram equals to 112 liters. 2 gram of hydrogen, that is 1 mole of H2, contains 6.02 into 10 to the power of 23 molecules. 10 gram of hydrogen contains what? Equals to 10.0 gram into 6.02 into 10 to the power of 23 molecules divided by 2.0 gram equals to 30 into 10 into 10 to the power of 23 molecules equals to 3.01 into 10 to the power of 24 molecules.